Good afternoon and welcome to the Weather Guru, all things weather education and world weather news. I'm your host, Tony. Thank you for joining me. Today we're going to be talking about weather education and we're going to be talking about weather fronts and air masses. This is the part one of a two-part series. And today we're going to be talking about the different types of weather fronts that we can experience here in the U.S. or around the world. And so I just want to start here. We can get right into the presentation. Weather fronts and air masses is part of Meteorology 101 series here. Thank you for joining me. Please be sure to hit that subscribe button for the Weather Guru. We are 100% passionate about weather and weather only. So please become a fan and please be sure to subscribe. More things coming in the future. Okay, so first of all, what is the definition of a front in weather terms? Well, a front is a boundary between two different air masses like cold and warm that contain different air densities. Now, normally they don't mix. So think of it as like oil and water. They can coexist, but they don't mix. So you can have a cold and warm air system, but they replace each other. So they replace or displace one another. In other words, you could be having a sunny 80-degree Fahrenheit day, but a cold front is approaching, and that cold front comes in and replaces the warm air, and within 24 hours, temperatures could drop as much as 15 to 20 degrees Fahrenheit for those daytime highs, and overnight lows subsequently could be much lower, and vice versa with a warm front replacing a cold front, etc. Now, these fronts can be stacked in the horizontal and the vertical planes in the atmosphere. And what I mean by that is that most of the weather that we experience here on this planet Earth happens in the stratosphere level of the atmosphere. And as you know from basic applied science, there's different levels of the atmosphere, from the stratosphere, the troposphere, the ionosphere, the exosphere, etc. But most of the weather happens from about 30,000 feet and below to the surface. And so most of these fronts can tap into the mid and upper levels of the atmosphere, as well as the low level conditions of the atmosphere as well, where we find our big cumulonimbus clouds and things of that nature, all the way up into the high cirrus clouds that we normally get after the passage of a frontal boundary or a high pressure system. It's based on air pressure. So these fronts, there can be fronts such as stationary, occluded, warm, and cold fronts as the designations of the leading edge of air when shown on the various weather maps. And I'm going to show you a classic weather map here from courtesy of weather.com here as we continue the presentation later on. So stationary fronts. A stationary front is just like it sounds. Listen, this is a front that has virtually no movement. Very much so like during hurricane season that's coming up later on in June 1st, by the way. You have a hurricane that becomes stationary. There's no movement. It's not moving to the north or south or east or west quadrants or anything. It's just no movement. So it is normally represented by red and blue triangles, a line drawn across the weather map, and you're going to see this visually here in just a couple of minutes after we get past the different fronts here. But these fronts can stall out and they can produce showers along the front, surface winds blow parallel to the front but in opposite directions on either side of the cold or warm air. So you basically have a boundary there where nothing is allowed to get past. It's not semi-permeable boundary like in biology where, some things are allowed to get past. No showers can get past. No surface winds can get past because they're blowing in opposite directions. And that's normally what a stationary front is. Now we have cold fronts where the leading edge of cold, dry, and deep air throughout the low, mid, and upper levels of the atmosphere, and you can feel a cold front coming because you feel a change in the wind direction. The winds are no longer coming from the west-southwest or from the east-southeast. They're now coming from the north and northwest. Whenever you watch a weather report, watch for these cold fronts and look at the wind direction that's coming. Most of the time, these wind directions are coming from the north, northwest. That is the cold Canadian polar vortex air coming down. And once you have that northwest wind, you can guarantee that colder temperatures and possibly snow showers for those northern tier folks, either lake effect or other kinds of snow could be possible. So it replaces the warm, humid, and moist air that could be present. Usually comes with a stiff north wind and marked temperature drops in 24 hours. So you can go from, if the cold front comes in the middle of the day, temperatures will be falling throughout the day. So you can be 70 degrees Fahrenheit in the morning, and then temperatures will be falling throughout the day as the cold front passes, and you could end up being 45 degrees in the afternoon with clear skies and a stiff breeze. Warm fronts, exactly the opposite. This is what the leading edge of the front is: warm and humid air. It's often accompanied by showers and thunderstorms sometimes, but it doesn't always have to be. Winds are typically from the south, coming up, bringing that warm Gulf moisture, and that's what a warm front does. It replaces that cool and dry air. That dry air and the water vapor represented by orange, typically on a lot of the water vapor images that you see on television or on these radar systems. And humid air is replaced by that. Winds typically are from the south, west, southwest, south, southwest, southeast, etc. Thunderstorms can accompany these on the leading edge. And this also, by the way, just as a caveat, this is where you start seeing things like you start getting into severe thunderstorms, sometimes typically issued. Sometimes you can get into things like you get these inflow notches, if you will, on these things that extend out as the warm air rushes out in advance of the front. Occluded fronts. This is a closed off front where the cold air and warm air meet up with each other. So this is like a marriage of the fronts, a happy marriage of fronts. So you can have a mixing or overrunning or training, if you will. It's overrunning of showers, or overrunning of warm and cold air, was a mixed front. And this is represented on the map by a purple line with blue and red triangles on the weather map. It's different than a dry line, but this is a closed off front, a occluded front there, where the cold and warm air, the boundary is not clear. It's hidden. That's why they call it occluded, because the boundary is not clear between the two. It's hidden. It's wrapped up with each other. And so now we're going to go to the map here, and I'm going to show you, this is the current surface map here for the United States of America for this weekend ending in April 11th, 2021. And I want to point out some features here for you here. As you can see, what do we have here? We have a cold front. You see the blue triangles and the line extending all the way down into the Gulf of Mexico, all the way down to the Gulf of Mexico. So we have this line here, this occluded front here. This cold front here. Okay. Now we also have this occluded boundary or stationary boundary here. You can see it's represented by the blue and red alternated triangles here. So look, we have a stationary boundary here. It's also an occluded front because you see the purple line extended down all the way down. So this is here. These H's, blue H's, are high pressure. This represents a clockwise flow of air, basically. So just think of a high pressure as a clockwise flow of air, usually clear skies with no showers present underneath it. So any state or any city that's under this is going to generally experience sunny skies, calm winds, and no showers, except in the case of what they call ridge runners. And these are showers that are running on the periphery of the high, on the outside, but they can never get under the high. They can never get under. That's something different. We'll talk about that later. Now, we also have a warm front here, or a warm sector here, as you can see from the North Carolina up into the Mid-Atlantic and the Delmarva region into Pennsylvania. You see this red line here with the triangles, as we've discussed earlier. That's a warm front here, or a warm sector. In this case, it's a wedge of warm air ahead of this cold front. Now, once the cold front passes through to the east and heads off to the Atlantic coastline past the Outer Banks, all of the temperatures here will be dropping from the eastern 2/3 of the United States, and the showers should clear out from that area. Now, north of this, there still will be some showers as they have this onshore flow off the Atlantic Ocean for those in New York, New Jersey, Connecticut, Massachusetts, up to Maine. Now, we also have these dotted lines. This is a trough boundary. That's something different. We will talk about that later. But as you can see, I just want to give you a picture of the different front systems that we have here in the United States and frankly around the world. Cold fronts here warm front, well, warm sector here, occluded front here, or stationary boundary here, leftover or active. Same up here in Canada. See here, we have the stationary front in Canada here, or occluded front right here in Eastern Ontario province and up into the Northern Territories. Same thing. L stands for low pressure. That the winds rotate counterclockwise around the low pressure like this, and all that means is that sometimes they can be a dry low like in the southwest, or a heat low but showers are not associated with them. Other times they can produce showers like here in the North Dakota, or thunderstorms like here in the Great Lakes, or showers that are non-severe but they are associated with showers. So this is your current map, and on the satellite and radar, when we switch here, you can see that this is how it presents itself. Down here we have that cold front here. You can see the clouds associated with it and the cold air leading. You can see the clouds in the southwest, in the southeast, associated with the occluded or warm front, stationary front type of deal. And you can see the high pressure here. See how there's no clouds here in the middle of the country because high pressure is dominating. High pressure, that sinking air allows for no clouds and no showers to be present underneath. So once again, this has been the Weather Guru for a quick explanation of warm fronts, cold fronts, occluded fronts, stationary fronts, and how they impact our weather here in the United States of America. Thank you for joining me. I look forward to seeing you on the next weather education lecture. Please be sure to hit that subscribe button. I'll talk to you very soon.